This is the Heat Exchanger Design Project for ME416, presented by Andrew Boyer and Evan Weeder. Background on the problem. MSU proposes a new plan to reduce the cooling costs of the High Performance Computing Center. The High Performance Computing Center outputs approximately 1 megawatt of thermal energy. And in order to cool the heat generated by the High Performance Computing Center, a large reservoir located near the engineering building contains about 10 million gallons of water and is discharged each day in order to accomplish this task. The Office of Infrastructure Planning and Facilities ideally would like to use the drinking water that is widely used around campus buildings. The main objective for this project was to design a shell and tube heat exchanger such that the geometry is comparatively compact and ease of serviceability such that the tube side is accessible for cleaning and sanitation. The temperature requirements are the drinkable water temperature should not increase more than 3 degrees Fahrenheit. Water flows out of the large reservoir at 57 degrees Fahrenheit, and the liquid dispersed heat needs to be less than 120 degrees Fahrenheit. For the size of the heat exchanger, it should not be more than 25 feet in length and the internal diameter piping of 14 inches. Further looking at the design parameters, it should be capable of using drinking water or a working fluid. The pressure drop should be minimized. The volumetric flow rate needs to withstand the 1 megawatt thermal energy. As for the codes and standards of the heat exchanger design, it should follow ASME's Boiler and Pressure Vessel Code, Section 8, Division 1. In order to find a proper heat exchanger, the team used a computing software to help develop a heat exchanger design. The program is called ASPID-1, and it was used to find an optimized design for a shell and tube heat exchanger that fits within the design requirements.
A 1 megawatt heat load was not achievable with the given mass flow rates and temperature changes. Therefore, the maximum possible heat load was approximately 325 kilowatts in order to meet all design parameters. Using aluminum 1060 as a cost-effective alternative, the total cost comes to $56,769 for the shell and tube heat exchanger. The team used 25-foot-long tubes in order to meet design parameters. On the shell side, there was an allowed 1.5 pounds per square inch pressure drop, and Aspen calculated a 0.61 pounds per square inch pressure drop. While on the tube side, there was an allowed 2 pounds per square inch pressure drop, and Aspen calculated a 1.04 pounds per square inch pressure drop. The designed heat exchanger will be able to effectively transfer 325 kilowatts of heat, and the hot water dispersed from the shell and tube heat exchanger will leave at 114.83 degrees Fahrenheit. In order to ensure easy cleaning and inspection, the team employed a horizontally mounted AEM configured shell and tube heat exchanger. Future improvements include reducing the overall size of the heat exchanger, reducing cost, and further minimizing the pressure drop. Questions?